everyone. I have the honor today to share with you a part of my research around recommendation systems and exactly my paper that is entitled An Optimized CRM Adapted to Big Data. I will start by introducing myself. I'm Abdurrahman Daif. I'm a PhD student at University Hassan II, Faculty of Science, Bimzik, Casablanca, Morocco. So, the agenda of my presentation will be as follows. I will start by an introduction, then I will go forward to present basics of CRM and its components, and after that I will talk about how we can enhance CRM application by big data, and I will present at the end a part of my approach to realize this, and I will finish by a conclusion and a perspective. So let's go back to the mid-20th century, where mass products and mass marketing changed the competitive landscape by this number of products and variety of product that is available for the consumer. Because when we start businesses, it starts by a product-centric strategy. And with this mass product and mass marketing landscape, it changes to be consumer and customer centric. So we put the focus only for the customer. And classic traditional purchasing that allowed the customer and the shopkeepers to spend the quality time to know each other has also changed. So the customer lost their uniqueness as they become just like an account number into a company. And companies lost their tracking capacity of the customer needs, because many customers are into the companies, and each customer doesn't have sufficient data that helps the company to understand the customer and to know well its habits and how it acts. But nowadays, companies are trying to re-establish their connection with and their relation with the new as well as the existing customer by utilizing marketing relationship strategy and advanced technology to let this happen. And this technology and this strategy is what we call CRM. CRM, if we can define it in a briefly manner, it stands for Customer Relationship Management. It's a business strategy that put the focus on meeting the customer needs by utilizing strategic and advanced technology. So this strategy will allow the company to well understand the customer, to record through each touch point any behavior and any action done by the customer. So we will have just like a history about what customer needs as support and what customer bought as a product, or what is his problem with the company. So CRM is three small letters with three core concepts. Customer, it's the heart of the organization. So each company try to win new customer and keep them as long as possible, and turn an individual sales into a long-term loyalty and long-term relationship. So the relationship will create a value for the company, but customer and relationship should be managed, and this management let this relation grow and let this relation to be for long term. But for those who feel that customer retention play a minor role on making the company or letting the company drawing a healthy bottom line, here you are some or few statistics that you might be interested in. So I will start by one of these statistics that was published by Gartner, applying the law of 2080. So it said that 80% of enterprises' profits is generated by 20% of its customers, and retention of actual customers costs 5 times less than acquisition of a new customer. And increasing the customer retention rate by 5% will make a profit growth of 75%. So, if we can give a summary of this, the objective of CRM and objective of each company is to decrease the customer retention, and create a customer loyalty. Around customer relationship management, there are 3 components or basic components: people, processes, and technology. So people, this is the capital of each company that will follow a processes using and utilizing a technology. But as you can see today, there are a lot of new concepts that is born around these 3 basic components, especially for the technology sides, where there are, for example, mobile trends, cloud trends, big data, and social media. In summary, we can say for the technology, what is this big shift that we are living today? It's this amount of data available for us, and we have to put a focus on this data available for us, because as we introduced it at the first of this presentation, there were a very, very strong relationship between the shopkeepers and customer. Why? Because the shopkeepers and customer were very close, and maybe they are neighbors, and maybe the customer creates his place on this shop, and the shopkeepers too are looking for the matching, or the perfect matching of the product with their consumers. So we want to rebuild and reestablish this knowledge that we will give to the companies regarding their customers. So, according to a market research associate software advice that presents the top reasons of replacing existing CRM system, we can recognize there are just 2 of them that present a very high percentage. So the first one is improving efficiency and need more and better features for the CRM system. And that's why we need to look and look for a new data and new resources of data to enhance this efficiency and integrate new features. But how to take advantage from this new data characteristic to enhance and enrich CRM and current CRM systems? So we need to really discuss the paradigm of big data. So what is exactly big data? Let's try to give a definition, a brief definition for this big data. So it started with progression. if we want to say that, it starts with the progression. Historically, data was accumulated by workers. I mean, employees and the company started to entering data into computer systems. And then this is involved to internet. So you can imagine now all internet users are signed up and they are entering their own data into, for example, Facebook or YouTube or Twitter, and they are entering new data and diversified data into internet and these websites. But then there is another level of progression. There are no machines that are accumulating and generating data, because no machine are very intelligent. You can imagine and you can scrutinize this huge number of smart buildings that are born, full of sensors, full of mirrors, and we can imagine too all satellites around the Earth that are monitoring Earth 24 hours a day, taking pictures and accumulating data. So this is the progression of the available data that we have. We started by employees, then users, and now there are machines. And if we can merge and integrate all these data with internal data, for sure we can have new knowledge. So big data, as we can say here, it was born from the number and amounts and this colossal data generated from terabyte to zettabyte, and then we have this variety created, because before we talk about structured data, and then there are the unstructured data, pictures, videos, tweets, comments, and each type of data you can imagine. There are velocity too, and velocity refers to the speed of entering data, storing data, and processing data, and then visualizing the data for the end users and experts. But after that and until now, we have other V's they will be added to the paradigm of big data. We have a value, because without the value that will be created through processing this new data, big data, it doesn't mean anything for the company and it doesn't mean anything for us. And veracity, it's how we can judge that these available data are true and we can rely on, and we can create an analysis and reporting based on these data. Is it true data or wrong data? Is it telling the truth or is it trying to tell anything? So, beginning the data to processor, at the beginning we bring the data to the processor to be processed. And we talk about relational databases. Through it we analyze available data. And nowadays, regarding the amount and the huge available data, we can't bring all this data to do a processor, and it won't be this process won't be able to process all this amount of data. So what is the solution? So we can talk about parallel processing. What is parallel processing? It's a number of servers where there are many processors, and then we will put the data into it and we will process this data in parallel. And this parallel processing will ensure the velocity and it will be able to process all the volume of available data. But how can this will be a reality and will be as a fact today? In fact, we will talk about two things and two technologies that let this happen and let this real, and we can use these techniques and tools to realize what was discussed as just a paper or research paper, and by the way, it's from Google. So the first tool we will talk about it's Hadoop. Hadoop, it's an open source framework written and running distributed applications. So with Hadoop we can manage all these servers, and this processing and this distributed processing to have at the end our result, and by ensuring accessible platform and something that is robust and scalable, because each time we bring more data we can add more servers, and then we will scale up the performance and scale up the amount of data available, and then we will have this equality and between the platform and processing power and amount of data, because each time we bring a server we will enhance and we will scale up the performance, and at the same time we have new data that is entering and accumulating, and then we will have this equalized formula between performance, platform, and the amount of data. So Hadoop, it's the tools, and it's a framework that will manage this parallel processing. The second thing is MapReduce, originating from Google papers, and it's a simple programming model. In fact, it's a pattern how we will distribute this data based on Hadoop, because when we give the data as an input, MapReduce will put on each server, like we say, it's a summary on which data or which server contain which data, and this summary will be centralized in a master. This master server will be as the coordinator between all these servers, and then we will have we can say and we can know which result in which server. It's for large-scale data processing, and it's clean abstraction for programmers. I mean, when programmers write a script code that is distributed into MapReduce framework, it's the programmer won't know on which server the data will be processed, on which server will have the result. The third one is Hive. Facebook started working on deploying a warehouse on Hadoop, and the problem was Facebook programmers and Facebook experts were very familiar with PHP language, and the idea was how can we use Hadoop, and our programmers and experts are using 100% PHP. So, and Hadoop, it's a Java-based software and platform. So they started to think about something that can make this easy for them to use Hadoop, and this is why we have as a result Hive. So Hive, it's like a platform, or we can say it's a sub-layer into Hadoop ecosystem that will support queries expressed in SQLite language, or we can say it's Hive QL, and programmers or experts can write SQL queries, and this for all programmers. I can't say that there is a programmer that can write a SQL query. So Hive will take the queries expressed by with SQLite, then put and will translate these queries into a distributed and Java code distributed to manipulate and to manage Hadoop, and let Hadoop then extract and manage data into servers. So it also includes Metastore that contains schema and statistics that are useful for data exploration, query optimization, and query compilation. The last tool and techniques we have is Pig. And Pig was initially developed at Yahoo to allow the same people using Apache Hadoop. It's the same paradigm and it's the same concept, except that Pig has it's a language itself, and which is called Pig Latin, and at the same time it presents an environment where the Pig Latin executed. So let's back now to the conceptual layers of CRM. So company, to have a vision, it should have a very strong knowledge, and this strong knowledge comes from technology and processes. So if we process a huge amount of data, for sure we have a strong knowledge. But after scrutinizing and comparing a lot of architecture and industrial architecture and the market, we recognize that there are three classes of technology into CRM application. The first one is highlighted with red, and it's operational CRM, and it presents all modules that make daily actions and daily operations for employees into the company. The second one is highlighted with yellow line, and it's collaborative CRM. It's the technology, or it's the class of technology that allows company to interact with the customer. The last one is the analytical CRM, when we can find data warehouses, databases, summary, and we have clean data that we will analyze and then have this final results. So I give some example of architecture, of industrial architecture, and I will start by Oracle, and you can see here that we have an analytical application, and that we present the analytical CRM part, and at the middle part we have also highlighted with red. This is the operational classes, and the last one is collaborative CRM technology. Same as HP now. The first part is collaborative technology, and at the middle we have operational technology, and at the end we have the last part, and it's analytical technology. So what we propose is an approach that will that is based on existing architecture, because there are two mirrors and two main approach. Even we say that all existing applications are obsolete and we can't use them, and we will knock companies' door and we will say, oh, you say, no, you can't use this application anymore, and we bring you a new version or new paradigm. No, this is an application that costs the application a lot of money, so we can't throw it like this. But the second approach that we follow is we will keep the same architecture. I mean, the collaborative technology, operational technology, and analytical technology, and we will add a new module that will present the ecosystem of big data. This ecosystem big data will ensure real-time analyzing, a very intelligent storage tool, and at the same time processing tools, because we have not only internal data but unstructured external data like YouTube videos or picture in Facebook or comments or tweets. So we should include all this data with the internal data to have at the end a very big amounts of data. And if we can process all this data, we are sure that we will have a very strong knowledge about our customers or about future customer or prospects. So our sales force will have a very huge knowledge about their prospects. And after analyzing the new data, we will have what we call unknown data. This unknown data is a result of analyzing the big data. So we have knowledge that will become an input for the new analyzing, and it's a cycle that will not stop, because processing it's on real time. So each time we have a new data, we will have a new processing, and so on. And this is our architecture, and it's not that easy, because we will study how we can include and integrate our module into diversified architecture, and all these industrial companies that put already its architecture. So as a conclusion, a new approach it consists on adding module as illustrated, and which present the big data ecosystem with sub-modules that each one will be responsible on something, and merging external data with internal data, and then the third type of data, it's what we baptize unknown data. But as a perspective, this won't be as easy as we can say, because as I said, we should more learn about technical integration issues with existing application and existing platform, and this communication between existing application and our module, or what we will propose as module. The second thing is we will apply standard processes as NDA and ADM. NDA, it stands for Model Driven Architecture, and Architecture Driven Modernization for ADM, to get a final architecture that will follow a standard process to propose and to present our architecture. And this is my presentation. I wish that that was very informative and it's very interesting for you, and I will thank you again for your time of attention, and thank you.